Alright, here in Unit 3, Lesson 2, we are going to deal with some rational exponents. What you say? Well, I've got here in the first objective, you can kind of see what I'm talking about. We're going to understand the meaning of a to the 1 over n, a to the m over n, and a to the negative m over n. And then we're going to use exponent rules and these rational exponents that we're going to talk about to simplify some expressions. So, let's get to it. First of all, definition. We're going to look at some definitions and then see some basic examples of how this is applied. A to the 1 over n. This is just another way to deal with a square root or a cube root or any kind of root. As you can see here in the definition, and I want to highlight this in a second. So if n is a positive integer greater than 1, so we're looking at bigger roots. We don't care about 1. We know anything to the first power is itself. So notice the number is right here. Wow, why did that just change to a pin? I do not know. I love how much of an adventure this thing is. Right, the number right there, n, the nth root of a. Okay, that's what we're talking about here. The nth root of a. If that's a real number, then we can write it in this format. And this is the important thing to know. A to the 1 over n. So in other words, let me give you a really basic example here. The square root of 5. Well, pretend that looks like a 5. What happened to my 5? I'm not real sure what happened to my 5. Oh, not much better. This can be written as 5 to the 1/2 power. That's what we're saying. It means the exact same thing. How about, for instance, let's take the cube root of 64. Well, this is equal to 64 to the 1/3 power. Same thing, right? We just take whatever the root is and put it in a fraction and make it an exponent. Now, hopefully you know that the cube root of 64 is 4, because 4 times 4 times 4 is 64. Right? So that's what we mean there. How about let's combine it and use it with something that looks maybe. Well, of course, I'll start out by erasing things instead of drawing for some unknown reason. Let's say we have 81x to the 8th, and we want to take that whole thing to the 1/4 power. Now, we can use this exponent just like we would an integer exponent. So we're going to take that 1/4 and apply it to both numbers inside of the parentheses. So this is 81 to the 1/4. Well, if my pen will write with me, it really does not want to. 81 to the 1/4 times, let me go ahead and put that x to the 8th in parentheses so we don't lose it. X to the 8th to the 1/4. Okay, well, first of all, 81 to the 1/4, or the 4th root of 81, is 3. If you didn't know that, now you do. A little fun trivia for you. And then x to the 8th to the 1/4. You should be applying the power rule here and multiplying your exponents. So 8 times 1/4 is 2. That means that leaves me with x to the 2nd, or x squared. So this would be my final answer, 3x squared, because I took 81 to the 1/4 power and x to the 8th to the 1/4 power. One last one. Let me scroll down here and give myself a little bit more space. Negative 9 to the 1/2. I just want to point something out here, just to be careful with your negative signs. Remember, if this negative sign is not in parentheses, let me draw parentheses here in a different color to make them stand out. If there were parentheses here, this would be a different problem. But there aren't. It's just negative 9 to the 1/2. So let me get rid of those parentheses. Okay, so we're saying take 9 to the 1/2 power. Well, 9 to the 1/2, or the square root of 9, we know that's 3. But then don't forget about that negative sign out front. So the answer to this is actually negative 3, not 3. So just be careful about that, because you will have one on your assignment that definitely involves a negative sign. Alright, moving right along. So that's a to the 1 over n. These others are all going to be similar, except now the only difference between this one and the first one is we're replacing that 1 with another number. So if m and n are any positive integers, and this is in lowest terms, then your sentence here, your equation is right here. That's the important thing. a to the m over n. So m over n is the power. It's the exponent we're raising a to. Of course, this is the same thing as the nth root of a to the m. Now, that's interesting. I'm making random marks on the screen. The nth root, just like before, we had the nth root of a, but before it was a to the first power. Now, instead of a to the first power, we have a to the mth power. Whatever m is, it goes with a under that root, under the radical sign. And notice here, this is kind of important, that these two are interchangeable. You can think about it in either order. You can take a to the mth power and then take the nth root, or you can take the nth root of a and then take whatever you get to the mth power. Mth is a funny word. Okay, so let's look at a few examples. Let's not, fine, we'll use green. It looks a little goofy. Negative 16 to the 3/4 power. Okay, so think about what we're saying. What we're saying is, first of all, this negative is not included, so let's leave it out front. It's just hanging out here. We're saying the 4th root of 16 to the 3rd power. Or in this case, it will be a lot easier for you if you switch this around. It actually makes more sense to think about it as negative the 4th root of 16, and then let's take that whole thing, let's do this first, and then take it to the 3rd power. The reason is this gives you smaller numbers to work with. So if we think about what we have here, because if you had taken 16 to the 3rd power first, that's a massive number, and then you have to take the 4th root of that. Now, of course, if you're doing it on a calculator, it's no big deal. You can handle it because your calculator can do it for you. But in understanding what's going on here, I think it's good to think about doing it in your head. So the first thing we want to do is this. Let me get a highlighter here that'll stand out. We want to do whatever's in parentheses here. Right? We want to do this. The 4th root of 16, or 16 to the 1/4 power. Hopefully by now you are comfortable enough with this to know that the 4th root of 16 is 2. So now what we're saying is we have this negative out here, and we have 2, and we're going to take it to the 3rd power. Well, 2 to the 3rd is just 8, so our answer is negative 8. Capiche? Good deal. Let's do another negative, but this time I'm going to put it in a parenthesis. So we're going to include it with the exponent, and we're going to go to the 2/3 power. So again, let me rewrite this with a radical sign. So that 3, the 2/3, the 3 is the root. So I'm going to have the 3rd root of negative 27, and I'm just going to go ahead and write it this way. I'm going to skip the step of writing the squared under the root, and I'm just going to go ahead and put the squared out here because I want to take that cube root first. Because again, this cube root is one that we know, we're familiar with. The cube root of negative 27, hopefully you remember that's negative 3. And again, if you don't, your calculator does. But of course, if you're doing this in a calculator, you should be able to just plug the original form in there. Right? Our goal here is to understand the connection between the two forms. So we're taking the cube root of negative 27. Well, the cube root of negative 27 is negative 3, because negative 3 times negative 3 times negative 3 will give you negative 27. Imagine that. And then we still have this exponent out here, squared. And so negative 3 squared is a positive 9. So notice a very important difference with that negative sign. In the first example, we had a negative answer. In this example, we have a positive answer. You have to be very careful about those negatives. And notice also in this step right here, I kept the negative 3 in parentheses because we want to think whatever we took the cube root of, that whole thing we have to square. So we want to include that negative. Let me get rid of that so I have a little space. And uno más, uno más. What if I make the base a fraction? That'll really screw with you a little bit. And take it to the 3/2 power. Now we're having a little fun here. Well, okay, let's think about this. First of all, quotient rule, which we'll discuss a lot more in the next section. We'll discuss all of these rules, but we've talked about quotient rule before. We know that we can split this fraction up. We can say 1 to the 3/2 over 9 to the 3/2. And we're just going to apply that exponent to each number individually. And of course, hopefully you know 1 to any power is 1. I don't care what number, what exponent is on there, that's always going to be a 1. Over, well, 9 to the 3/2. Maybe by now you can do this without writing it out in this form, but if not, then that's okay. The square root, now I put a 2 there, but you know, you don't have to have a 2 for a square root, but I'm just putting it there to emphasize what we're doing, where that exponent went. So we're taking the square root of 9 and we're going to cube that. That's what the 3/2 power means, right? So we've got 1 on top over, think about what we have on the bottom. The square root of 9 is 3, and 3 cubed is 27. So 1/9 to the 3/2 power is 1/27. Okay. Well, we'll just chug right along then, and I will hop across the pond and turn British. I don't know what happened there, but I did. Alright, so now we're going to take the last one we just did. We just did a to the m over n power, right up here, right? Now, instead of thinking about that, we're going to chuck a little negative sign in there. That's going to throw everybody for a loop. Chuck a little negative sign, and my pin's going to stop working. I think my pin is telling me don't talk like that. I can't stand it. Alright, really, I don't know what's going on, but I'm going to get rid of that. Okay. Just like if you have, let's think about a basic integer here. Let me use a different color too. If you have, that's a bad color, 3 to the -4th power. That's the same as 1 over 3 to the 4th power. Right? You just take that negative exponent, you flip it down to the bottom, and then you got a positive exponent. Well, that's all we're saying here. The same thing applies when the exponent is a fraction. So if you've got a negative exponent, you can take it and flip it down to the bottom of a fraction, and now it becomes a positive exponent. It turns out you can also just flip the fractional exponent, but we won't go there, that's okay. So for instance, let's look at this. (16 to the -3/4). What we're saying is this is equal to 1 over 16 to the +3/4. Alright, enough British, that's hurting my mouth. And then, since we already know what 16 to the 3/4 is, right? Of course you do, because we just talked about it, a problem back up here. Let's look right up there. We just talked about it. 16 to the 3/4 turned out to be 8. It just happened to have a negative sign in front of it. So this time, 16 to the 3/4 will be just +8, no negative signs involved. So we've got 1 over 8. Bueno? Bueno. I like how I ask you if that's good, as if you can respond to me. Huh. Habit. -27 to the -2/3 power equals, well again, 1 over all that business to the +2/3 power. And let's think about this one more time, right? 1 on top over, well, we take the cube root, whatever this bottom number is in the fraction, that's my root. I take the cube root of -27, which is -3, so let's just write it like that. We'll just do one extra step. And then we square it, right? Whatever we get from the cube root, we're going to square it. So my answer here is 1/9. Super, 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 super. Alright, let's review some exponent rules real quick before we go on to simplifying some more complicated expressions. And I just need to give myself a little bit more space. So, because we got to remind ourselves that exponent rules apply to fractions as well. b to the 1/3 times b to the 5/3. This is product rule, right? And remember, whenever you use product rule, you just add the exponents. So this turns out to be, well, looky there, I just magically erased 1/3. Wasn't even touching it, but somehow I erased it. So when we use product rule, we add the exponents. So this is b to the, oh, now I'm really doing fun things, bringing up extra menus. I should stop touching the screen with my hand. That would really help. b to the 1/3 times b to the 5/3 means add your exponents. So 1/3 plus 5/3 is 6/3, right? So really what we have here is b to the 2nd power. I'm just reducing 6/3 to 2. Bueno, bueno. Alright, that was your basic example of product rule, right? Okay, so then we've got, think about a different example, x to the 1/2 times x to the 1/3. Well, we know we need to add those fractions, but of course if we're going to add fractions, we need a common denominator. So quickly, this is just a review. 1/2 and 1/3, they both go into 6, right? So 6 is our common denominator. So this is going to be x to the 3/6, if I could write, plus 2/6. That's 1/2 and 1/3 converted to sixths. So we have x to the 5/6. Oh, my 6 got a little smushed there. Is our answer. Alright, so let's see a example of quotient rule. 7 to the 1/3 over 7 to the 4/3. Interesting. Now remember, with quotient rule we subtract the exponents. So this is actually 7 to the 1/3 minus 4/3. Well, 1/3 minus 4/3 is actually negative 3/3, or negative 1. So what I have here is 7 to the negative 1. But of course we know if we have a negative exponent, we can make it a positive exponent by flipping it down to the bottom of the fraction. So that's actually just 1/7. 1 over 7 to the 1. 7 to the 1 is 7. In case anybody's wondering what happened there, if I went too quick, let me just add that in. We flipped it down to the bottom so that we had a positive exponent, and then 7 to the 1st power is just 7. Alright, let's look at one that's more complicated, and then we'll move on to something else. We've got, let me use a different color so these don't run together. We've got 2x to the 2/5 y to the negative 1/3, because I like to make it as complicated as I can, because it's more fun that way. All of that over x squared y. I'm not sure why my line didn't get extended there. Okay, so first of all, let's just look at the top of the fraction and do what we can here. Let's apply that exponent, that 5, to everything in the parentheses. So first I'm going to say, well, 2 to the 5th power. 2 to the 5th power is 32. Next I'm going to take x to the 2/5 to the 5th power. And this is where we have to apply power rule, right? Because we're actually multiplying the exponents. Let me actually write it out here so that we see what's going on. Make sure that we're all clear here. We're saying x to the 2/5 to the 5th. And then I would have y to the negative 1/3 also to the 5th. And all of this is still over x squared y. And I'm clearly going to need more space, so why not just go ahead and get it. Oh, too far. Too far. Okay, there we go. So now let's rewrite what we have on top. Well, on top we've got 32x to the what power? Well, 2/5 times 5 is actually just 2. So that's convenient. And then we have y to the negative 5/3 power. Not as convenient. And all of this is over x squared y. Well, look at what we've got going on here. I've got an x squared on top and an x squared on bottom. Those are going to cancel each other out. That's nice. So then what I just need to focus on are my y's. Remember, there's a little understood 1 here for this exponent on that y. So if I use quotient rule here, let me switch back to blue and come down below. We know I've got a 32. Well, we knew that, but my eraser, no, let's just try that again. We know we've got a 32, and then we have y to the negative 5/3 minus 1, right? Because we have to subtract our exponents when we use quotient rule. So this, it turns out to be 32y to the, now you got to get a common denominator, right, to subtract. So just think of 1 as, let me just come in here and get a little clever, change this 1 into 3/3. So this should be a negative 8/3. Now be careful when you're doing this assignment in My Math Lab. It may tell you to write your answer with no negative exponents. It may say use only positive exponents. Well, in that case, we need to do one more step, and we need to flip this y term down to the bottom, and then it would be 32 over y to the 8/3. And now we have positive exponents only, and there's our answer. Super! Alright. Now the last thing you'll have to do is you will have to simplify. Let me get myself extra space again. You will have to simplify some radical expressions using rational exponents. Rational exponents, keep in mind when I say that, I just mean an exponent that is a fraction. A fraction is a rational number. So for instance, the 8th root of x to the 4th. Well, let's think about what that means. If we change this 8th root business into a rational exponent, remember we can write this as x to the 4th to the 1/8 power. Right? Because taking the 8th root is the exact same as taking something to the 1/8 power. So now, applying power rule, we have x to the 4/8. Well, I really would love it if my pen would cooperate, but you know it won't. And why would it start now? X to the 4/8, which of course we can reduce to x to the 1/2. Now again, when you're doing these problems, I'm almost certain that My Math Lab wants it with a radical sign. So you don't need to leave it in this format. You need to go one step further. Now that we've got x to the 1/2, well, we know that we can rewrite that as the square root of x. And that's how you would enter your answer online on the homework. Okay. How about this one? Now this is one that'll really make you think. This will be our last example, and then I'll be done for this unit. No, for this lesson. Okay. Now this you really have to think about, because if you just say, okay, well, I could say this is 25 to the 1/6 power. That's true, but that doesn't allow us to reduce anything. You have to get a little bit clever here. Think what we know about 25. Well, we know that 25 is 5 squared. So if I come in here and rewrite 25 as 5 squared, now I've still got that to the 1/6 power. Right? So all I did is I just rewrote 25 as 5 squared. That's a true statement. Well, now I can simplify this, because then this is, using power rule, 5 to the 2/6, which of course reduces to 5 to the 1/3. And now I can rewrite that as the cube root of 5. For 5 to the 1/3 is the cube root of 5. Okay, hopefully that should give you what you need to complete the assignment. And as always, send me your questions.